Hello there, and welcome to the Sleepless Scientist, a quiet place in the cosmos where your thoughts can unwind and knowledge becomes a soft lullaby for the night. Tonight's journey will carry us into a question that has lived on the border between wonder and worry for centuries. Is time travel possible without paradoxes? Not the flashing portals of science fiction, not the frantic loops that tie themselves into logical knots, but something gentler, something that whispers maybe, just maybe. The universe already knows how to let us slip backward or forward in time without tearing itself apart. But before you settle in and get cozy, I'd love if you could take a moment to like this video and subscribe, only if you truly find these quiet explorations enjoyable. And when you're ready, leave a comment to let me know where in the world you're listening from and what time it is for you right now. It's always such a joy to see all the places we gather from, each in our own little slice of time. Now feel free to dim the lights, maybe turn on a fan for a soft background hum, and let's gently begin our journey into time travel together. And if your mind begins to wander, that's perfectly fine. Let it drift. We'll still be here, quietly unfolding the story. Imagine for a moment that you could reach into the past and nudge it ever so slightly. Perhaps you missed a train by 1 minute and wished you could step back just long enough to slip through the doors. Perhaps there's a word you spoke too hastily, one you would give anything to take back, or a chance you let pass by, a chance that still lingers like an echo in your memory. These small regrets, the soft yearning for a second chance, are often where the dream of time travel begins. It isn't always about grand adventures or rewriting history on a cosmic scale. Sometimes it is simply about wanting to relive a moment that mattered, or to repair a thread that frayed too soon. Popular culture has given this yearning a face, a soundtrack, and a set of rules. You might picture a gleaming car with gull-wing doors tearing across an empty street as lightning flashes overhead. Back to the Future's iconic promise that a machine could carry us both backward and forward through time. Or perhaps you imagine a blue police box, larger on the inside than the outside, carrying its eccentric pilot from one century to another, as in Doctor Who. Maybe it is the haunting landscapes of Interstellar, where time itself becomes slippery under the weight of black holes. These stories have shaped the way we imagine time travel, exciting, dramatic, often dangerous, and nearly always tangled in paradoxes. A traveller goes back, changes one small thing, and suddenly the present collapses under the contradiction. And yet the very persistence of these tales suggests something deeper. We return to them again and again, not just for the adventure, but for the comfort of exploring what might happen if the rules of time could be bent, if the linear road we walk could be curved into a loop. The paradoxes are frightening, yes, but they're also strangely reassuring, because they let us play with the idea of freedom from regret, while still reminding us that our world holds together. Paradoxes are, after all, puzzles dressed as warnings. The grandfather paradox is the most famous of them. If you were to travel into the past and prevent your own grandparent from meeting their partner, you would erase your own existence and therefore never travel back in the first place. The paradox is a snake eating its tail, forever devouring its own logic. Another is the bootstrap paradox, in which an object or an idea appears from nowhere, its origin lost in the loop of time. A scientist hands a young composer a symphony, who later becomes the very person to pass it back to that scientist in their youth. Where did the music truly come from? It seems to exist without beginning, an echo with no source. These puzzles haunt our imagination because they feel like hard walls in the soft dream of time travel. They tell us, you may wish, you may imagine, but you cannot step beyond the paradox. And yet, perhaps these walls are not walls at all, but mirrors reflecting our own limited way of thinking about time. As you lie there tonight, perhaps feeling the pull of the pillow or the warmth of a blanket, consider how time already feels slippery in your daily life. A joyful moment with friends seems to vanish in an instant, while a long wait in a queue stretches endlessly. Memories fold in upon themselves, sometimes so vivid they feel like they're happening again, sometimes so faint you wonder if they occurred at all. Even in dreams, your mind leaps without hesitation between childhood and adulthood, between imagined futures and impossible scenes. In this way, we already drift across time in quiet ways that do not collapse under paradox, but instead become part of the texture of living. This is the spirit in which we will explore time travel tonight. Not as a frantic attempt to break the universe, but as a gentle wondering about whether paradoxes are truly as final as they appear. Could the universe itself carry built-in solutions? Could the very fabric of physics hold us steady even as we step back or forward? Might there be principles, hidden, subtle, that allow for loops without contradictions, journeys without logical disaster? We will travel slowly, of course. We will wander through relativity, with its already proven gifts of moving forward in time. We will tiptoe into closed time-like curves, strange loops in space-time that Einstein's equations whisper about. We will pause with Novikov, who suggested the universe knows how to keep itself consistent. We will listen to the quantum world, where Deutsch showed how probabilities might bend around paradoxes. We will drift into the block universe, where past, present and future stand quietly, together, and into the many worlds interpretation, where every possibility has its own stage. And finally, we will return to our own small lives, where dreams, regrets and moments of joy remind us why the idea of time travel lingers so tenderly in the human mind. So tonight, if you feel the tug of regret or the longing to step backward for just a second, let this exploration be a balm. We may not find a time machine parked outside the door, but we will find that time is stranger, softer, and perhaps more forgiving than the paradoxes suggest. And maybe, by the end, you will see that the dream of paradox-free time travel is not only possible in theory, but already with us in the quiet ways we move through memory, imagination, and the future rushing gently toward us. When we first begin to think about time travel, it feels playful, like a riddle you might toss around at a cafe table with friends. What would you change, if you could? Would you go back to high school to give your younger self advice? Or perhaps slip into the past to witness a moment of history, quietly standing at the edge while the pyramids rose stone by stone? The thought is deliciously tempting because it makes time feel less like a one-way road and more like a playground, filled with swings and loops and hidden slides. And yet, almost as soon as the imagination takes flight, something heavier drifts in, pulling us down from the clouds. The word that arrives, again and again, is paradox. A paradox is not just a contradiction. It is a story that folds in on itself until meaning seems to vanish. The most famous of them all is the grandfather paradox. You may already know the outline, but let us retell it slowly, as if it were a bedtime tale with an unsettling twist. Imagine a traveller stepping into a machine that whirs and hums until it delivers them into the past, decades before their own birth. They wander the streets of a city still dressed in horse-drawn carriages, or fields not yet touched by highways. At some point, whether by accident or intention, they prevent their own grandparent from meeting their partner. No meeting means no child means no parent, and no parent means no traveller to make the journey. The story devours itself. If the traveller never exists, how could they have gone back? But if they never went back, then their grandparent did meet their partner, and so the traveller exists once more. The loop closes and opens endlessly, never quite resolving. It is a haunting tale because it touches on identity. It asks, if you remove one link in the chain that led to you, do you vanish like a candle blown out? And more troubling still, how could you ever know which link matters most? A smile exchanged on a street corner, a letter delivered late, a choice to move from one town to another. Each may ripple forward until it shapes an entire life. The paradox is not just about your grandparent. It is about the fragile, contingent nature of existence itself. The bootstrap paradox has a different flavour. but an equally strange taste. Picture a composer who dreams of writing a great symphony, but never quite manages to find the melody. One day, a visitor from the future brings them the sheet music to their masterpiece. The composer learns it, performs it, and in time becomes famous for that very piece. Years later, when they have aged and the notes are worn into their fingers, they travel back and hand the score to their younger self. But where did the symphony truly come from? It was never composed in the ordinary sense. It simply existed, passed around in a loop with no beginning and no end. You can find echoes of this paradox in everyday life if you squint just right. Think of a recipe you learned from a friend who admitted they first learned it from you, though you cannot recall ever inventing it. Or imagine a rumour whispered in a school hallway that you hear again and again until you forget who started it. In the bootstrap paradox, the origin is swallowed, leaving only the endless circulation. Both paradoxes, grandfather and bootstrap, work like guardrails for our imagination. They warn us that time travel is not as simple as turning back the pages of a diary. They insist that history is fragile, that cause and effect cannot be pulled apart without something breaking. Yet the question remains, are these paradoxes proof that time travel is impossible? Or are they simply signs that our understanding of time is incomplete? Think for a moment about how paradoxes appear in less exotic places. Optical illusions are, in a way, paradoxes of vision. You see two lines that look unequal, yet when measured they are identical. The contradiction exists not in the world, but in the way your eyes and brain process the shapes. Similarly, paradoxes in time might not be flaws in the universe, but flaws in our storytelling, born from trying to squeeze time into the narrow channels of our ordinary logic. Consider also how nature often resists our simplest expectations. The earth feels flat beneath your feet, yet it curves. The sun seems to travel across the sky, yet it is we who turn. Water appears solid when frozen, yet it is constantly vibrating at the level of molecules. Again and again, reality surprises us with patterns stranger than the ones we assumed. Might time itself hold such surprises, ones that gently unravel our fear of paradoxes? Popular culture has not helped our nerves. From Back to the Future to the Butterfly Effect, stories lean into chaos, showing how one tiny change in the past can unravel the present entirely. Spill a drink on the wrong person, and suddenly whole families never exist. Step on a butterfly, and the future twists into something unrecognizable. These tales are thrilling, but they are also exaggerated. They assume the universe is fragile glass, ready to shatter at the slightest touch. Yet physics often suggests something sturdier, something more self-correcting, something that can bend without breaking. And so, when we picture time travel, our first instinct is to worry. We see paradoxes rising like storm clouds, filling the sky with impossible thunder. But perhaps that instinct says more about our imagination than about time itself. Perhaps paradoxes haunt us because we are used to thinking in straight lines. One cause, one effect, one arrow of time. When those lines curl into loops, our minds rebel, insisting that contradictions must follow. But the universe has never promised to obey the neatness of our diagrams. As we move deeper into this journey, we will begin to meet ideas, both philosophical and scientific, that offer gentler paths. Some suggest that history bends around our actions to keep itself whole, much as a river flows around a rock, without ceasing its course. Others whisper that there are many timelines, many branches, so no single one is ever truly disrupted. Still others propose that all of time is already laid out, a tapestry woven in its entirety, so paradoxes dissolve like mist. For now, it is enough to sit with the unease, to recognize why paradoxes have such power over us. They speak to our desire to control what we cannot control, to rewrite what is already written, to find shortcuts through a fabric that may not allow seams. They are frightening, yes, but also strangely comforting, because they give shape to our limits. And just as a dream feels more vivid for its strange impossibility, so too does the dream of time travel remain irresistible, even when paradoxes stand in the way. If paradoxes make time travel sound impossible, then relativity offers us the gentle reminder that it has already been happening quietly and steadily every single day. You do not need a DeLorean with flashing lights, nor a wormhole stretched across galaxies to slip into the future at a different pace. All you need is motion, gravity, and the patience to measure time's uneven flow. This is where Albert Einstein enters our story, not with a time machine hidden in his laboratory, but with equations that bent our very sense of reality. At the start of the 20th century, time seemed as simple as the ticking of a clock. It was assumed that a second here in one place would match a second anywhere else in the universe, as if an invisible metronome beat evenly across all of creation. Yet Einstein suggested something radical. Time is not absolute, but relative. The speed at which it flows depends on how fast you're moving and how strongly gravity holds you. To the human eye and the daily clock on your wall, these differences are imperceptible. But to the universe, they're as real as the pull of the tides. Picture a train rushing down the tracks at nearly the speed of light, carrying two friends. One stays on Earth, watching the train streak by. The other is inside, drinking coffee and watching the blur of scenery. According to Einstein's special relativity, the friend on the train experiences time more slowly than the friend who remains on Earth. When they meet again, the traveller will have aged less. It sounds like the premise of a fable, but it has been proven with precise clocks, synchronized and then flown around the world on aircraft or sent up in satellites. Upon their return, they show that time indeed passed differently. The effect is small at human speeds, but at cosmic speeds it becomes profound. You do not need to imagine hypothetical trains either. Look up to the skies, and you will find time dilation at work. Global Positioning System satellites, the quiet companions guiding you when you check your phone for directions, experience both special and general relativity. They move quickly relative to Earth, which makes their onboard clocks tick a little slower, yet they're also farther from Earth's gravity, which makes their clocks tick a little faster. The combined effect is that without correction, GPS would drift by kilometers each day, making it useless. Engineers constantly adjust for these relativistic effects, and so every time you find the nearest cafe or navigate a winding road, you are leaning on a system that works only because time travel into the future has been quietly measured and accounted for. Even your own body is experiencing these effects right now. Gravity's pull is slightly stronger at your feet than at your head. This means time is passing a fraction more slowly near the ground than higher up. It is a difference so tiny that you would never notice it, but it can be measured with atomic clocks. In a sense, your head is always living in the future of your feet, however minutely. Time's unevenness is stitched into every step you take, every breath you draw, every day you live without noticing. Astronauts have also given us living demonstrations. Consider the case of Scott Kelly, the NASA astronaut who spent nearly a year aboard the International Space Station, orbiting the Earth at more than 27,000 kilometers per hour. When he returned, his twin brother, who had remained on Earth, was fractionally older than him. The difference was microscopic, just milliseconds, but it was real. Scott Kelly had travelled slightly into the future compared to his twin, carried there by the relativistic flow of time at orbital speeds. There is something strangely comforting about this. We often imagine time travel as violent, dramatic, a sudden leap through flashing lights. But relativity shows us that time travel can also be subtle, a gentle stretching or compressing of moments, like a rubber band drawn a little tighter here, a little looser there. You're already a time traveller moving into tomorrow at the ordinary pace of 1 second per second, yet with countless tiny deviations, measured only by the most patient of clocks. Think of it like music. Two musicians might play the same melody, but but one leans into the rhythm, stretching certain notes, while the other keeps a strict tempo. Both reach the end of the piece, but not in the same way. Relativity makes the universe into a grand orchestra where each clock, each heartbeat, each orbit keeps its own subtle timing. The paradoxes that haunt our imagination belong mostly to the idea of travelling backward, but relativity gives us a paradox-free gift. Moving forward in time at different speeds, measurable, predictable, and beautifully consistent with the laws of physics. Of course, the temptation is to ask, if we can go forward, can we ever come back? Here the universe hesitates, holding its secrets close. Relativity does not forbid closed loops, but it also does not offer them freely. Instead, it shows us a door ajar, inviting us to recognize that time is not rigid, not uniform but flexible, curved, and deeply connected to motion and gravity. So when you glance at your watch, or notice the seconds scrolling across your phone screen, remember that those ticks are not universal. They are local, yours alone. A clock a few meters away, higher up or moving faster, is keeping time differently, even if your eyes cannot tell. We live not in a single river of time, but in countless streams, flowing side by side, sometimes converging, sometimes diverging, yet always heading forward. And in this quiet recognition, we discover something profound. Time travel is not only possible, it is inevitable. We're all slipping into the future at unique rates, whether by the pull of gravity, the speed of motion, or the choices that guide our lives. No paradox is required, just the steady, whispering flow of relativity, carrying us gently onward. Relativity, for all its elegance, did more than simply stretch time. It also opened a door into something far stranger. Einstein's equations, when extended beyond the gentle time dilation of satellites and trains, suggest that the very fabric of space-time can be bent and folded into loops. These loops are not flights of fantasy, but emerge naturally in the mathematics, like hidden patterns in a tapestry that only reveal themselves when the cloth is twisted. Physicists call them closed time-like curves, but you can think of them more simply as circles in time, a path where a traveller could set out on a journey and eventually return not only to the same place, but to the very same moment from which they began. To imagine this, picture walking around your neighbourhood block. You leave your front door, follow the curve of the street past familiar houses, cross the corner where the old oak tree leans, and eventually arrive back where you started. You have not contradicted yourself. You have simply traced a loop. Now imagine time itself behaving in the same way, allowing you to step into a curve so that after walking long enough, you arrive not at tomorrow or next year, but at yesterday. It sounds like a fable, but within Einstein's equations, such loops are possible. One of the simplest examples comes from solutions involving massive rotating objects. Consider a star, or even more dramatically, a black hole that spins. The rotation drags space-time around with it, a phenomenon called frame dragging. If the conditions are extreme enough, the dragging can be so powerful that the paths of time themselves curve back on one another. Instead of flowing forward, they circle. A traveller caught in such a region might trace that circle and return to an earlier point. In science fiction, this might be portrayed as stepping into a shimmering vortex, but in reality it would be less like walking into a portal and more like following the geometry of the universe wherever it leads. Another famous solution is the wormhole, often nicknamed an Einstein-Rosen bridge. Imagine space-time as a sheet of paper. If you want to get from one dot to another far away, you could walk across the page. But if you fold the paper, the two dots touch, and you can step directly across. That is what a wormhole does. It folds space-time, connecting two distant points. Now, if one end of the wormhole is moved or accelerated differently from the other, perhaps carried close to a massive star, or propelled near the speed of light, time itself flows differently at each mouth. The result is a shortcut not only through space, but through time. Step into one end, and you might emerge not in another galaxy, but in another year. It is important to pause here, because these ideas can quickly feel overwhelming, like staring at an intricate pattern too long until the shapes blur. Closed time-like curves and wormholes are not everyday experiences. They are mathematical possibilities teased out of the equations, and yet they are consistent with the physics we know. They do not break Einstein's rules, they emerge from them. That is what makes them both exhilarating and unsettling. Everyday anchors help us bring the idea closer. Think of an old-fashioned record player. The needle follows the groove of the record, circling endlessly, yet playing a story that feels like it is moving forward in time. Now imagine if the groove itself looped back, so that after listening to a verse, you found yourself again at the beginning of the song without realizing it. Closed time-like curves are like hidden grooves in the record of the universe. They may not exist everywhere, but if they do, they would allow time to repeat itself, not metaphorically, but literally. Of course, questions immediately rise. If such loops exist, why have we not met travellers from the future? Why do we not see the evidence of histories rewritten? Here is where paradoxes return to haunt us, for a circle in time almost begs for contradiction. But the mathematics itself does not forbid them. It simply lays out the possibility, as if to say, the rules are broader than you thought, but whether nature uses them is another question. Stephen Hawking once proposed his chronology protection conjecture, suggesting that the universe might conspire to prevent such loops from ever becoming real. Perhaps any attempt to create a closed, time-like curve would collapse under its own energy, like a soap bubble bursting the moment you try to touch it. In that view, the equations allow the possibility, but the physical world refuses to grant it. It is a comforting thought, a kind of cosmic safety net, though it remains an unproven idea. And yet, there are hints that the universe is not quite so cautious. Theoretical physicists have discovered entire solutions to Einstein's equations, where closed time-like curves appear naturally, such as in the strange geometry known as the Gödel universe, named after the logician Kurt Gödel. In that model, the entire cosmos rotates, and time itself spirals back upon itself. Though our universe does not appear to behave this way, the fact that such a solution exists suggests that time's geometry may be far stranger than we assume. So, as you listen tonight, consider how quietly radical this is. You already live with time dilation every time your phone consults a satellite. That is relativity's gentle gift, paradox-free. But lurking deeper in the same mathematics are suggestions that loops and shortcuts may also be possible. Perhaps they are rare, perhaps they are fragile, perhaps they are forbidden by laws we have not yet discovered, but they are not dismissed outright. They are written into the equations as naturally as orbits and falling apples, and there is a kind of comfort in that. The paradoxes that trouble our imaginations are not simply products of folklore or science fiction. They are invitations, pointing to the edges of what physics allows. Closed time-like curves remind us that the universe does not think in straight lines. It curls, it bends, it loops, and it may even fold back upon itself in ways that let yesterday remain within reach. If closed time-like curves are written quietly into Einstein's equations, why do they leave so many scientists shifting uneasily in their chairs? On paper, the loops are elegant. They arise naturally, like vines curling around the frame of a trellis, but in practice they threaten to unravel everything we know about how cause and effect works, and physics, for all its boldness, is still a discipline that leans on the steady hand of logic. Without it, even the most beautiful equations can collapse into nonsense. Imagine for a moment that you are playing a game of chess. Every move has consequences, each piece sliding forward under strict rules. Now imagine that one square on the board allows you to loop backward, erasing a move you already made, while the other pieces keep marching ahead. What does the game even mean anymore? Can you still win, or does the very idea of winning dissolve because the timeline of moves no longer holds together? That is how many physicists feel about time loops. They are not impossible in the equations, but they threaten the very logic on which those equations rest. Stephen Hawking gave this unease a name, the chronology protection conjecture. He suggested that perhaps the universe has a way of guarding itself against paradoxes, not with a cosmic policeman or a stern warning sign, but through the quiet mechanics of physical law. The moment you try to create a loop, quantum fluctuations would surge, energy would spike, and the structure would collapse like a bridge too thin to bear its own weight. In Hawking's words, the laws of physics conspire to prevent time travel on a macroscopic scale. It was less an equation than a hunch, but one born from the instinct that the universe, for all its strangeness, prefers consistency. There is something comforting in this picture. A child learning to walk discovers quickly that the floor does not vanish beneath their feet. Gravity does not pause mid-step. The world, while sometimes surprising, is also profoundly reliable. Hawking's conjecture imagines time as equally reliable, refusing to allow tricks that would topple cause and effect. And yet, just as comforting as it may be, it remains only a conjecture. Physics has not proven it. The equations still allow loops. The protection is at best a guess about how reality might behave. Think about the role of rules in everyday life. When you play a card game with friends, the rules matter not because they are cosmic truths, but because without them the game falls apart. If one player insists on drawing cards whenever they like, or inventing moves no one else can follow, the experience dissolves into chaos. The laws of physics are our universe's rules. They make the game playable, ensuring that the sunrise follows the night, that rivers flow downhill, that energy is neither created nor destroyed. To allow a time traveller to break causality would be like allowing a player to bend the rules until victory means nothing. But here is where physics hesitates. The rules are not something we impose. They are discovered. They reveal themselves in experiments, in observations, in equations written to match the stars and the atoms. If the equations whisper of loops, can we simply forbid them out of discomfort? Or do we need to look deeper to see whether the apparent contradiction hides a new layer of truth? One way to picture this is to think of a maze. You walk its corridors, certain that a wall blocks your path, yet when you press, you find the wall is only a curtain, and behind it lies another passage. Paradoxes feel like walls, but perhaps they are curtains, hinting that the real structure of time is broader than we imagined. Physics gets nervous not because the loops are mathematically forbidden, but because they press against our understanding of logic, of free will, of what it means to live in a world where cause leads to effect. Everyday life rarely forces us to think in such terms. You boil water and it turns to steam. You drop a cup and it shatters. The arrow of time points forward, steady and clear. But in the deep mathematics of relativity and quantum theory, time does not always behave so neatly. It twists, curves, and sometimes even loops back, like a path on a hillside that doubles upon itself until you're no longer sure which direction is truly forward. Scientists are not immune to wonder. Many admit that the possibility of closed time-like curves is both thrilling and terrifying. It suggests universes where stories never end, where beginnings and endings blur, where memory itself could be a circle rather than a line. But they also know that without careful guardrails, the loops could unravel physics, leaving us with contradictions that make prediction impossible. And prediction, after all, is what gives science its power, the ability to say, with confidence, that if you drop an apple, it will fall, and if you heat water, it will boil. Without that reliability, the world becomes chaos. So physics stands at a delicate edge. On one side, the mathematics points toward loops and paradoxes, whispering that time may be far stranger than we dare imagine. On the other, the instinct for order and consistency urges caution, suggesting that the universe itself may quietly protect its chronology. Perhaps we will one day discover a deeper law that reconciles these views, a rule hidden in the quantum foam of space-time that explains why some paths are allowed and others collapse. For now, we are left with the unease, a quiet nervousness that loops may exist in theory, but unravel in reality. As you lie here tonight, listening to these thoughts drift by, you might notice that the feeling is not unlike drifting into sleep. Dreams often present you with paradoxes, places you know but have never visited, people who shift faces mid-conversation, stories that make no sense yet feel utterly real. You wake and smile, recognizing that the contradiction belonged not to the world, but to the dream itself. Physics, too, may find that the paradoxes of time are less about reality and more about the limits of our perspective. Perhaps, like dreams, they are invitations to look more closely, to accept that what feels impossible might only be unfamiliar. Among all the thought experiments that have followed time travel through philosophy, physics, and popular imagination, none has lingered as stubbornly as the grandfather paradox. It is the one people tend to bring up at parties when the subject of time travel drifts across the conversation, often delivered with a triumphant smile as though it were the checkmate move in an argument. But what if you went back and prevented your own grandparent from meeting? Wouldn't you erase yourself and therefore never make the trip in the first place? The question sounds simple, but its implications spiral in every direction, like ripples across a pond that never quite fade. Let us retell it gently, as if it were a story whispered before sleep. You are a traveller who has discovered a way to step backward through time. You adjust the dials, step into the machine, and in a blink find yourself wandering through a world that existed long before you were born. The fashions are older, the cars heavier, the music scratchier through wooden radios. At some point you encounter one of your grandparents, perhaps standing at a train station, suitcase in hand. For reasons that are never quite explained, sometimes by accident, sometimes by choice, you intervene in such a way that the meeting with their partner never happens. No meeting means no parent, and no parent means no you. If you never existed, how could you have travelled back? But if you never travelled back, then the meeting did happen, and you were born after all. The loop closes, then tears, then closes again, an endless flickering between contradiction and consistency. It is the purest form of paradox because it undermines its own premise. You exist and do not exist in the same breath. Logic begins to fray at the edges, and unlike mathematical puzzles, which often come with neat solutions, this one seems to hold no escape. What makes the paradox so haunting is not only its logical structure, but its intimacy. It is not about faceless strangers in the past, but about the very chain of events that led to you sitting here, breathing, listening, thinking. Every family story, every fragile coincidence that brought two people together at the right time and place, becomes a domino in a delicate arrangement. Remove one, and the entire line collapses. The paradox is terrifying because it places your very existence on the line, not as an abstract curiosity, but as the fragile product of a history you can never fully control. Of course, people have enjoyed creating variations. Instead of grandparents, some tell the story of a traveller going back to prevent their younger self from inventing a device. If the invention never happens, then the machine does not exist, and the journey cannot take place. Others speak of erasing a favourite book. A novelist, inspired by a story, travels back to meet its author, only to discover that they themselves end up dictating the story that becomes the inspiration for their own journey. Where, then, did the book truly come from? In each variation, the loop closes on itself, making the traveller both cause and effect, origin and consequence, actor and victim of their own timeline. There is a certain humour in imagining these loops, because they play with the absurd. Picture trying to stop yourself from sending an email, only to realise that the very attempt ensures the email is sent. Or imagine warning your younger self not to attend a concert, but by appearing at that very concert to deliver the warning, you guarantee your younger self attends. The paradox becomes almost slapstick, the universe pulling the rug out from under you at the exact moment you thought you had escaped its rules. And yet, beneath the humour lies a serious weight. The grandfather paradox feels like a wall, solid and immovable, because it strikes at the foundation of causality. We are used to thinking of causes leading to effects in neat succession. If you plant a seed, it grows into a tree. If you strike a match, it bursts into flame. But if you prevent the seed from ever being planted while still expecting the tree, or snuff out the match while still demanding the flame, you collide with contradiction. In a universe where paradoxes like this can exist, how can any chain of cause and effect be trusted? This is why scientists and philosophers have wrestled with it so intensely. The paradox is not a mere riddle. It is a challenge to the entire structure of logic and physics. Some have responded by declaring that backward time travel must therefore be impossible, full stop. Others, more daring, suggest that the paradox is not a wall but a mirror, showing us the limits of our imagination. Perhaps the rules of time are broader than the neat diagrams we draw, and what looks like contradiction from one perspective is simply a kind of consistency we have not yet learned to see. To bring the idea closer, think of stories that fold back on themselves. A novel that begins with its ending, so that every page you read is both cause and consequence of what you already know. Or a piece of music that ends where it began, the final chord echoing the first, making the whole composition into a circle rather than a line. We do not call such stories or songs paradoxes, we call them clever. Perhaps time, if it truly loops, would be more like that, a circle with its own coherence, rather than the messy contradiction we fear. Still, for now, the grandfather paradox stands tall in the imagination, daring us to resolve it. It is the spectre raised in every casual conversation about time travel, the proof offered by skeptics, the warning whispered by storytellers. And maybe that is why it endures, not because it is unsolvable, but because it reminds us how delicate our place in the universe feels. We are the product of countless moments, each fragile, each dependent on those before. To tug at those threads, even in imagination, is to risk unravelling ourselves. And so, as you drift deeper into this exploration, let the paradox rest gently in your mind. It is a puzzle, yes, but also a story about belonging, about the fragile miracle of being here at all. If it feels like a wall, perhaps it is also a kind of protection, reminding us that some things, like our own existence, are not so easily rewritten. If the grandfather paradox is the wall that blocks the imagination of time travel, then Igor Novikov's proposal is the small hidden gate, built neatly into that wall. It does not smash through contradiction, nor does it pretend the problem isn't there. Instead, it offers a gentler possibility. What if paradoxes simply cannot happen? Not because time travel is forbidden, but because the universe itself is built to prevent contradictions from ever forming? This is the heart of the Novikov self-consistency principle, a mouthful of words that, in essence, say the timeline will always arrange itself so that everything fits. Imagine a river flowing down a mountain slope. You place a rock into its path, expecting the water to halt. Instead, the current swirls, diverts, and carries on around the obstacle, still finding its way to the ocean. You cannot stop the river's journey by placing a single stone. You can only change the shape of the ripples along the way. According to Novikov, time behaves like that river. Whatever you try to do in the past, the stream of events bends around your actions, ensuring that the final outcome remains consistent. Think of a traveller attempting to prevent their grandparent from meeting. Each attempt fails in some subtle way, not because fate intervenes with dramatic thunderbolts, but because the very structure of reality refuses to allow contradiction. Perhaps the train is delayed, perhaps the words are never spoken, perhaps the traveller simply trips on a loose stone and misses the critical moment. Whatever the detail, the grandparent meets their partner, the parent is born, and so is the traveller who believed they could intervene. The loop closes, not with a crash, but with a quiet sigh of inevitability. To bring this closer, imagine something as ordinary as carrying a glass of water across the room. You stumble, the glass tilts, and it seems certain to fall. Yet, in some last-minute twist of balance, you catch it just before it hits the ground. Your clumsy motion becomes part of the story of the glass not breaking, not the cause of its destruction. In Novikov's picture of time, your actions are woven into the outcome that was always consistent. Even the near misses, the stumbles, the mistaken gestures become the reasons why contradiction never arrives. This view can feel both reassuring and unsettling. On one hand, it promises safety. You cannot undo your own existence. You cannot collapse history, because the universe simply won't let you. On the other hand, it whispers of destiny, of a script already written, in which your choices, though freely felt, always lead to the same conclusion. Some find this troubling, but perhaps it is no more troubling than the way a melody is written into sheet music. The violinist may play with passion, with pauses and flourishes, but the notes still lead to the same ending. The music is richer because of interpretation, not because the notes can change. Science fiction has played with this principle in quieter ways than the dramatic paradox tales. You may recall films or stories where a time traveller attempts to alter the past only to discover that their actions were, in fact, the very cause of the history they sought to prevent. In such stories, the universe does not fight them with thunder and lightning. It simply folds their efforts back into consistency. The attempt to prevent a war sparks the event that ensures it happens. The effort to save someone becomes the reason they are remembered. History, in this sense, is not fragile glass but supple fabric, stretching and folding but never tearing. Everyday life offers hints of this same resilience. Consider how often you try to control events, only to find that your intervention becomes part of the outcome itself. You hurry to catch a bus, and in your rush you drop your keys, delaying yourself until the next bus arrives. Precisely the one that carries a friend you have not seen in years, or you plan a conversation carefully, determined to change its course, and yet the words come out differently, leading to the very conclusion you were trying to avoid. We laugh at such twists of fate, but they are reminders that outcomes often find ways of holding steady despite our intentions. Novikov's principle takes that everyday intuition and applies it to the grand canvas of time. The loops may exist, the travellers may wander, but the story remains intact. No paradoxes survive because the universe bends itself toward consistency. The paradox dissolves not by being solved, but by being impossible. There is a gentleness in this idea, one that feels appropriate as we drift deeper into the night. If you worry that stepping back through time would destroy everything, Novikov suggests instead that you would be woven seamlessly into what was already there. You could act, you could speak, you could even stumble, but the outcome would fold you into its tapestry without contradiction. It is not so much a restriction as it is a reassurance, the universe's way of saying, you belong here, and nothing you do can unravel the belonging. Perhaps that is why the principle has appealed to so many. It is not as dramatic as branching universes or as dizzying as probability loops. It is instead quietly consistent. It makes time travel imaginable without making history fragile. It offers us a way to dream of journeys backward without waking into chaos. And maybe, if you let your thoughts wander as you lie here, you can feel the comfort in that. Life often feels chaotic, uncertain, filled with regrets about choices you might have made differently. But perhaps, in some deeper sense, every choice is already part of a consistent story, one that carries you forward like a river that never forgets its path. You may stumble, you may splash, you may set stones in the stream, but still the water flows, and still it arrives at the sea. If Novikov's principle is a gentle reassurance that paradoxes cannot truly tear the fabric of history, then the bootstrap paradox is the quiet mystery that lingers when we realize that not everything needs an origin. It is a thought experiment that does not collapse into contradiction the way the grandfather paradox does. Instead, it curls neatly into a loop, and asks with a mischievous smile, does it really matter if something has no beginning, as long as it is consistent? The name comes not from shoes, but from the old expression to pull yourself up by your own bootstraps, an impossible task that suggests self-sufficiency taken to an absurd extreme. The paradox is exactly that, an object or idea that seems to pull itself into existence without ever being created in the ordinary sense. To picture it, imagine a composer handed a symphony from the future. They study it, perform it, and grow famous for it. Many years later, they travel back in time and hand the very same score to their younger self, who then repeats the cycle. The music exists, but where did it come from? It was never written, never imagined from nothing. It is trapped in a perfect loop, its origin swallowed by time. There are many playful versions of this story. A scientist who discovers a formula only because their future self left it in a notebook. A traveller who learns a poem only to become the one who first recited it centuries earlier. Even a recipe works as an example. You might picture someone proudly baking a cake from a recipe they learned years ago, only to discover that the original source was themselves, delivering it back in time in a tidy circle. No baker ever invented it. The cake simply exists, hopping between years like a well-travelled guest. The paradox is unsettling because our minds are trained to look for beginnings. We like to ask where something came from, to trace a line back to its source. A story has an author, a song has a composer, a recipe has a first cook, a house has a builder. Yet the bootstrap paradox suggests that time travel could produce objects or ideas that exist without ever being born. They are self-contained, like a ring without a start or end. Think of it like a storybook where the first page tells you to skip ahead to the last, and the last page directs you back to the first. You could read forever, circling through the pages, and the story would make sense in its own way. It would not matter that no one wrote the missing page one. The loop sustains itself. Some find this comforting. It means paradoxes can be resolved not by erasing contradictions, but by embracing circles. Others find it troubling, because it hints at the possibility of knowledge or creations that do not belong to anyone, ideas untethered from origin. Philosophers sometimes wonder whether this erases the very notion of creativity. If Beethoven only performed a symphony given to him by his future self, was he truly its composer, or was the music never composed at all? But perhaps the more generous view is to see the loop itself as a kind of author. The paradox creates a new category of origin, not the hand of a single person, but the structure of time itself. The symphony exists because time allows the loop to exist. The recipe is baked because the cycle makes it inevitable. And in that sense, the bootstrap paradox is not a contradiction, but an expansion of how we think about causality. Everyday life offers tiny echoes of this feeling. Have you ever told a story so many times that you forget who first told it to you? Or repeated a phrase until the original source is lost, leaving only the comfort of familiarity? Language itself is full of bootstrap loops, with sayings and idioms passed around until their first author is forgotten, and yet they still carry meaning. We do not demand to know who first said once upon a time before enjoying a fairy tale. Perhaps time travel would create such idioms on a grander scale, loops of knowledge, unmoored from beginnings, but perfectly functional nonetheless. Another way to soften the paradox is to think of circles we already accept. The Earth orbits the Sun, the Moon orbits the Earth, and the cycle continues without a true beginning. Seasons turn in loops, with winter giving way to spring, summer, to autumn, and back again. You do not ask which spring was the first spring, or which sunrise was the first sunrise. They simply are. The bootstrap paradox might feel strange because we expect creativity to have an origin, but perhaps some things, like circles, are whole without a starting point. There is also a playful quality to the paradox that makes it linger in science fiction. It allows writers to explore mysteries without breaking consistency. A time traveller might give Shakespeare his own plays, or bring back advanced technology to an earlier age. The story is not about contradictions, but about the uncanny feeling of encountering something that exists only because it always has. And perhaps, as you listen tonight, you can let the idea settle without rushing to resolve it. Some mysteries are gentler when left as mysteries. The bootstrap paradox is one of them. It does not demand panic nor insist on impossibility. It simply loops quietly, a circle of existence that shrugs off the need for beginnings. Philosophically, it invites a softer question. If the loop is consistent, is it really a paradox at all? Or is it only our insistence on linear origins that makes it feel strange? Maybe the universe is less concerned with beginnings than we are. Maybe it cares more about patterns holding together than about tracing every thread to its first knot. In the stillness of night, this idea can even be comforting. You're here, in this moment, not because you can trace every detail of history back to its first spark, but because the loop of your life carries forward, day by day, memory by memory. Whether time is a line or a circle, what matters most is that the story holds, that you are part of it, that the music continues to play. By now, we have wandered through paradoxes that feel like brick walls and principles that soothe them into rivers and circles. But there is still another guest waiting patiently at the edge of the conversation. It is the guest who always arrives late at the party, slightly unpredictable, often confusing, but absolutely essential. Quantum mechanics. If relativity shows us the grand curves of the universe, galaxies spinning, black holes bending light, time stretching under gravity, then quantum mechanics shows us the quiet, invisible dance of the smallest things, particles so tiny that they refuse to behave like anything we know. Stepping into the quantum world is like stepping into a dream where rules bend just enough to keep you awake. At this scale, an electron is not a marble, but a blur, not a dot, but a cloud of possibilities. Light is both a wave and a particle. A cat, at least in thought experiments, can be both alive and not alive until someone peeks into the box. These are not just whimsical ideas. They are realities tested in laboratories, written into equations, confirmed by experiment after experiment. And it is here, in this strange twilight between possibility and certainty, that time-travel paradoxes begin to soften. Think first of the notion of superposition. If you flip a coin, you expect heads or tails, one outcome fixed by gravity, motion, and chance. But in the quantum world, before you look, the coin is not just one or the other, it is both, spinning in a space where possibilities coexist. Only when you glance at it, when the system interacts with the outside world, does the coin settle into heads or tails. This is how electrons, photons, and other particles live, spread across probabilities until observation draws them into a single thread. Now picture paradoxes through this lens. If a time traveller sets out to change the past, perhaps the universe does not slam into contradiction. Perhaps it drifts, like the quantum coin, into a cloud of probabilities, waiting for consistency to emerge. Instead of collapsing into, yes, you erased yourself, or no, you didn't, the loop adjusts into a self-consistent outcome that honours both the traveller's action and the timeline's stability. It is as if paradoxes dissolve not by being forbidden, but by being distributed across possibilities until only the consistent threads survive. Everyday life gives us echoes of this idea, even if we rarely call them quantum. Imagine planning a dinner with friends. Until the evening arrives, many possibilities exist. Perhaps someone brings dessert, perhaps no one does, perhaps the meal is burned, perhaps it is perfect. All those outcomes linger in the air, unchosen but possible, until the moment you sit at the table. Only then does the night settle into one path. You may not be thinking in probabilities, but you are living in them. Quantum mechanics suggests that nature itself operates this way at its most fundamental level. There is also something deeply comforting about the quantum perspective when applied to time travel. Instead of rigid contradictions, we find a system that bends. Instead of walls, we find doors left ajar. If paradoxes seem impossible in classical logic, perhaps they are survivable in quantum logic, where outcomes do not need to be fixed from the start but can adjust, flex, and settle into coherence. Of course, the quantum world can feel unsettling. It is not always easy to imagine coins that are both heads and tails, or cats that are both alive and not alive. But then again, everyday experience has its own moments of ambiguity. Think of a dream that is both real and unreal while you're inside it, or the strange déjà vu, when the present feels like it is happening for the second time. Our minds already entertain these blurry states, where certainty arrives only after the fact. Quantum mechanics simply tells us that the universe itself may play by similar rules. And so, when physicists explore time travel through the lens of quantum theory, they often find that paradoxes soften. A traveller may still step into the past, but instead of creating contradictions, the probabilities shift, ensuring that whatever happens remains consistent with the traveller's own history. It is as if the universe politely rearranges itself, smoothing over the wrinkles like a careful hand brushing fabric. The story remains intact, not by forbidding loops, but by adjusting the details until they harmonise. Think of a choir singing in many voices. At first, the sound is chaotic, notes overlapping, some rising, some falling. Yet gradually, the voices align, the chords form, and harmony emerges. Quantum mechanics suggests the universe may behave in a similar way. Even when time travel threatens discord, the probabilities shift until the melody resolves, leaving paradoxes dissolved into consistency. It is worth remembering that quantum theory is not a fringe idea or an untested speculation. It is one of the most successful frameworks in science, powering the semiconductors in your phone, the lasers in your DVD player, the magnetic resonance imaging machines in hospitals. Its strangeness is not theoretical, it is practical, woven into daily life through technology. And so, when it whispers that paradoxes may be less frightening than they appear, it is not mere fantasy but an extension of the same logic that already guides our world. As you lie here, perhaps you can let that comfort sink in. The universe, at its smallest scale, is not brittle glass waiting to shatter under contradiction. It is supple, flexible, a dance of possibilities that finds harmony even when the steps are unexpected. Paradoxes may frighten us because we imagine time as a straight line, fragile and easy to snap. But quantum mechanics suggests a softer picture. Time, like particles, may carry within it the ability to flex, to adjust, to settle into harmony no matter how strange the journey. And so, when quantum mechanics enters the room, the conversation about time travel shifts. No longer a story of hard contradictions, it becomes a story of probabilities, of adjustments, of harmony emerging from uncertainty. It is not a final answer, but it is a gentle reminder. Perhaps the universe is kinder than our paradoxes suggest. If quantum mechanics teaches us that reality is a cloud of possibilities, then David Deutsch, a physicist with a taste for bold ideas, offered a way to think about time travel within that cloud without fear of contradiction. His proposal, known simply as the Deutsch model, suggests that the rules of quantum physics bend themselves to ensure paradoxes never appear. It is not that paradoxes are waiting to trip us up, only that the universe is far too careful a storyteller to let its plot fall apart. The idea can be softened into a simple picture. Imagine a line at a cafe, filled with people waiting for their morning coffee. At first, it looks chaotic. Some customers are indecisive, others are impatient, and the barista is juggling multiple orders. Yet somehow, by the time everyone has their drink, no one is left behind. Even if the line reshuffles, even if someone steps out for a moment, the cafe finds a way to serve each person in turn. According to Deutsch, the universe behaves in a similar fashion when faced with time travel. The probabilities may shuffle, the outcomes may adjust, But in the end, consistency is served to everyone in the line. Consider again the grandfather paradox, which seemed so terrifying a few sessions ago. In the classical picture, if you go back and prevent your grandparent from meeting, the contradiction collapses logic entirely. But in the quantum picture, your attempt becomes part of a spectrum of probabilities. Some possibilities vanish, others emerge, and what remains is a set of consistent outcomes where paradoxes never take hold. It is as if the universe gently closes the contradictory doors before you can walk through them. There is a playful elegance to this. Instead of a stern rule saying no time travel allowed, Deutsch's model suggests that time travel is permitted, but only in ways that maintain consistency. You might feel like you are free to attempt anything, but the quantum rules quietly guide you toward outcomes that harmonize with history. It is like trying to write a sentence with random letters, only to find that the letters rearrange themselves into something grammatically correct. The universe, in this model, is an editor that never allows nonsense to reach the page. Everyday life has its echoes of this kind of quiet correction. Think of the times when you try to make an awkward joke, and your friends somehow reshape it with laughter and comments so that it lands better than you intended. Or when you fumble in the kitchen, spilling flour across the counter, but the recipe still produces a cake that tastes just fine. Life, in small ways, has a habit of smoothing rough edges, of bending accidents into outcomes that still work. Deutsch's model imagines that time itself behaves with this same forgiving resilience, ensuring the story remains coherent no matter how strange the journey. From a scientific perspective, this works because quantum mechanics allows many possible histories to coexist until probabilities settle. The Deutsch model proposes that whenever a time traveller steps into the past, the probabilities adjust in such a way that contradictions are automatically filtered out. In effect, the universe never allows you to walk into a paradox because only the self-consistent probabilities are realised. It is not that paradoxes lurk as dangers, it is that they never materialise at all. This vision can sound abstract, but it can also feel surprisingly human. It portrays the universe as a careful host, one who arranges the evening so that all guests feel comfortable, no matter how unpredictable the conversations may be. The traveller may knock over a glass, arrive late, or say something unexpected, but the party continues without falling apart. Some find this picture deeply reassuring. It suggests that time travel is not doomed by contradiction, but cushioned by probability. Others find it eerie, as though free will is an illusion, because the universe will always nudge you toward consistent choices. Yet perhaps free will has always lived alongside quiet nudges. Your life is filled with limits, boundaries, and subtle corrections that keep you from drifting into impossibility. You may choose your path, but gravity still holds you, biology still shapes you, and the passage of time still carries you forward. To bring the idea closer still, imagine writing in the margins of a book. You might scribble notes, underline phrases, even draw arrows to reorder events. But when the book is read again, the story itself has not collapsed. The annotations may add flavour or shift interpretation, but the core narrative remains intact. In Deutsch's view, time travel is like scribbling in the margins of history. The probabilities rearrange themselves, but the book never contradicts itself. Humour helps soften the abstractness here. If you think of time travellers lining up at a cosmic cafe, you might imagine the universe as the barista, smiling patiently as it reorganises the queue. No matter how many times the travellers shuffle, skip ahead, or try to cut the line, the barista ensures that everyone eventually gets their drink and no order is ever missed. The paradox of someone receiving a coffee before they order it, or ordering it without existing, simply never happens because the cafe does not permit such nonsense to reach the counter. And so, in the Deutsch model, paradoxes are less like looming disasters and more like impossible sentences that simply never appear. The universe edits them out before they reach the page, leaving only consistent stories to be told, as you lie here tonight, Perhaps you can let that vision settle like a warm blanket. The idea that the universe has built-in safeguards, quiet corrections that keep time from unravelling, offers a gentle comfort. Paradoxes may haunt our imagination, but in the quantum world they dissolve into harmony, probabilities rearranged until the melody plays without dissonance. You do not need to fear contradiction, because the story of time, in this model, is always edited into coherence. If the Deutsch model comforts us with the thought that probabilities quietly rearrange themselves into consistency, then the many worlds interpretation takes a bolder step. It suggests that when faced with contradictions, the universe does not bend or edit itself, it simply multiplies. Instead of forcing every possibility into a single timeline, it allows each one its own stage, branching into countless parallel realities. In this picture, paradoxes do not threaten logic because no single version of events needs to carry the entire weight of possibility. Every outcome happens somewhere, and so nothing is forbidden. It may sound extravagant at first, like using an entire forest of paper just to write one note. But many physicists and philosophers find the idea strangely elegant, because it removes the need for the universe to make hard choices. Instead of choosing between heads or tails, it allows both to occur, each in its own branch of reality. The coin lands on heads in one universe and on tails in another. Both outcomes are real, both histories unfold, and both travellers go on their way without contradiction. To picture this in a gentler way, imagine standing at a crossroads. You could turn left toward the quiet road lined with trees, or you could turn right toward the bustling street filled with cafes and laughter. In ordinary life, you pick one path and the other fades into imagination. But in the many worlds view, both paths are walked. Another version of you enjoys the laughter of the cafes, while this version of you wanders under the trees. Neither path cancels the other, both belong. The paradox of choosing disappears because every choice is real somewhere. Now bring this to time travel. Suppose you step back in time and try to change the past. In the single thread view, contradiction looms immediately. You alter history and risk erasing yourself. But in the many worlds view, your action simply creates a new branch. In one universe, the past unfolds as it always did, leading to the present you came from. In another, your intervention shapes a new history, one where events diverge. You have not broken logic. You have only stepped from one path into another. Everyday life offers metaphors that echo this branching. Think of conversations that could have gone in many directions. A word chosen carefully may lead to laughter. A careless phrase may lead to silence. Both outcomes feel possible, even if only one was realized. The many worlds interpretation suggests that in the broader tapestry of reality, both conversations exist, spoken in parallel threads. Or imagine a book with multiple endings, each printed on different pages. You may only read one at a time, but all are written, waiting for you. This interpretation does something remarkable for time travel paradoxes. The grandfather paradox dissolves entirely. If you go back and prevent your grandparent from meeting, you do not erase yourself. You simply create a branch where you never existed. But the original branch, where you did exist, continues undisturbed. The paradox was never a contradiction, only a misunderstanding of how reality might hold multiple versions of history. It is a liberating thought, though also a dizzying one. For if every possibility is realized somewhere, then every choice you might have made is being lived by another you, in another branch. There is a version of you who took the other job offer, who stayed in the other city, who married someone else, who caught the train instead of missing it. Each of those versions carries on with their own memories, unaware of the others, each believing their story is the only one. There is both comfort and melancholy in this. Comfort because it means no choice is ever truly lost. Some version of you explores it. Melancholy because the version you inhabit can never reach across the branches. The roads diverge, and though all are walked, you can only follow one. Science fiction has played with this idea endlessly, creating stories where travellers slip between universes, meeting alternate versions of themselves or glimpsing histories where familiar events took different turns. Sometimes these tales are thrilling, sometimes unsettling, but at their heart they speak to a human truth. The sense that life is full of paths untaken, and we cannot help but wonder what lies down them. This many worlds interpretation turns that wondering into a physics proposal, suggesting that those paths are not only imagined but real, written into the structure of reality itself. To make this gentler still, think of how memory works. You may look back on a moment and imagine how differently it could have gone. Each imagined scenario is vivid, filled with detail. In your mind, it feels almost real. The many worlds view simply says, perhaps it is real, not in your mind alone, but in the fabric of the cosmos, spun into a parallel branch where those details unfolded as you imagined. As you rest tonight, let this idea drift softly. Paradoxes dissolve not by being forbidden, but by being distributed. Every outcome has its home, every possibility its stage. You need not fear that one action will unravel the universe, because the universe, in this view, contains room for all of them. Like a vast forest of branching paths, it allows every step to find its way. And perhaps that is why the many worlds interpretation feels so dreamlike. Dreams, after all, often give us glimpses of lives we did not live, choices we did not make, paths we did not take. We wake with the sense that something else is real just beyond our reach. The many worlds interpretation suggests that this feeling is not only poetic but scientific, a hint that reality itself may be far broader than the single line we call our own. Up to now, we have spoken of time as something slippery and flexible, capable of bending, branching, or adjusting itself to avoid contradiction. Yet there is another way of thinking about time that removes paradoxes by refusing to see time as a moving river at all. Instead of a flow carrying us from past to present to future, this picture suggests that all of time, every second that ever was and ever will be, already exists, laid out in its entirety. Physicists sometimes call this the block universe, though it may be easier to think of it as a grand library. In this library, every book has already been written, every chapter complete, every page filled with ink. You may wander the shelves and open a book to a particular moment, but the story itself is not changing. The book is what it is, unaltered, entire, and whole. In this vision, the present moment is not being created in front of us like a trail, freshly painted as we walk. It is simply the page we happen to be reading right now. Behind us, the earlier pages are still there. Ahead of us, the pages we have not yet read are also already waiting. We may feel the suspense of turning to the next chapter, but the ending is not being written as we approach it. It has already been there all along. This way of seeing time can feel strange, because it runs against the grain of how we live. We experience the world as unfolding, as if tomorrow is not yet decided, as if yesterday is gone. Yet the block universe view says, yesterday still exists, tomorrow already exists, and today is simply the page we're open to. If you step backward in this block, you're not changing the past, because the past is already fixed. You're simply revisiting a chapter already written, a scene preserved in the book. To make this image softer still, think of a film reel. When you watch a movie, you see one frame at a time, strung together to create the illusion of motion. But all the frames already exist, printed on the strip of film. The ending is already captured, even if you have not reached it yet. You cannot alter the film by watching it differently. You can only experience it one moment after another. The block universe suggests that time itself is like that film reel. Our lives play out frame by frame, but every frame already belongs to the reel. What does this mean for paradoxes? Quite simply, it means they cannot occur. If the past is already real, it cannot be changed. If the future is already real, it cannot be prevented. In such a universe, the grandfather paradox is not a problem because you cannot undo what has already been done. The loop is closed before you even begin. The traveller who steps into the past is not rewriting history. They are simply participating in the events that were always there, woven into the block. The attempt to change something is itself part of the story that never changes. This may sound rigid, but there is a quiet beauty in it. Think of memories. A childhood moment, long past, remains vivid in your mind. You cannot alter it. You cannot re-enter it and change what you said or did. Yet the fact that it is unchangeable is also what makes it precious. You revisit it not to edit, but to feel its presence again. In a block universe, all of time is like that. Fixed, unchanging, but eternally present. Of course, this raises deep questions about free will. If the future is already written, does that mean your choices are illusions? Are you simply following a script you cannot alter? Here the metaphors help again. Think of a play performed on stage. The script is written, the lines arranged. Yet each actor still performs with passion, bringing meaning and nuance to every moment. The play is fixed, but the experience is alive. Or imagine listening to a symphony you know by heart. You cannot change the notes, but you can feel the swell of each phrase as if for the first time. The block universe may be less about denying free will than about reframing it. Your freedom lies not in rewriting the score, but in playing your part with depth and presence. Some people find this view unsettling, as if it drains life of spontaneity. But perhaps it can also be seen as a source of peace. If every moment already belongs, then nothing is ever truly lost. The laughter of a childhood afternoon, the warmth of a hug, the colours of a sunset, all remain forever inscribed in the block. They do not vanish when the clock ticks forward. They are preserved, just as surely as words on a page or frames on a reel. When you think of time in this way, paradox-free time travel feels almost trivial. To travel backward would be like moving your finger to an earlier line in the book. You would not alter the line, you would simply read it again. To travel forward would be to skip ahead to a page you have not yet opened. The story does not change. Your perspective does. Paradox is avoided not by flexibility but by permanence. As you lie here tonight, perhaps let this idea comfort you. Imagine your life as a book already written, its chapters complete. The surprises you feel are real, the emotions are real, but they unfold within a structure that already exists. You cannot lose a moment because every moment is already held. The past is still there, the future is already waiting, and the present is simply where you are turning the page. And so the block universe offers a paradox-free vision of time travel. Not chaotic, not fragile, but calm, steady, unchanging. All of time at once, a library filled with books that never vanish, a reel of film with every frame preserved. It may not match the way we feel time rushing past us, but it offers something different. The quiet assurance that every moment is safe, already belonging, forever real. The block universe, with its suggestion that every moment is already etched into reality, invites us into one of the oldest questions humans have ever asked. What does it mean to be free? If the past, present and future are all equally real, if each second is fixed like a bead on a string, then where in that structure does free will live? Are we actors reading lines in a play whose ending has already been written? Or do we still have space to choose, to shape, to live as though the future is open? These are not only questions for philosophers in armchairs or physicists with chalkboards. They are questions each of us has felt in quieter ways. Perhaps you have wondered whether a decision you made long ago was truly free, or whether it was inevitable, shaped by every choice and circumstance that came before it. Perhaps you've thought about destiny, about whether meeting a friend or partner was chance, or whether it was somehow written into the flow of your life. The block universe amplifies these questions. suggesting that everything, every meeting, every word, every silence already belongs to the tapestry. To make this picture gentle, imagine rewatching a favourite movie. You know how it ends. You know which lines are spoken, which scenes make you laugh, which moments bring tears. Yet each time you watch, you lean into the story as though it were new. The actors deliver their lines with fresh energy. The music swells in your chest. The suspense feels real, even though you know the outcome. In the same way, the block universe suggests that our lives, though already written, are still fully lived. The fact that the ending exists does not make the journey less meaningful. If anything, it allows you to savour the details more deeply, knowing that every scene belongs. Or think of a symphony you love. The notes are fixed, printed on the sheet music, rehearsed into muscle memory. Yet when the orchestra plays, there is still passion, still tension, still release. You would not say the music lacks meaning because the notes are predetermined. The meaning arises in the performance, in the way the musicians inhabit the structure and make it come alive. Perhaps our lives too are performances within a score already composed. We do not create the notes, but we give them voice. This view does not erase free will, it reshapes it. Instead of free will being the power to alter the script, perhaps it is the power to live the script fully, to bring richness to each line. Just as actors bring themselves to their roles, no two performances of the same play ever feel identical. We bring ourselves to each moment, even if the moment itself is fixed. The block universe does not need to drain life of spontaneity. It can remind us that meaning is found not in rewriting history, but in inhabiting it with depth. There is also a soothing comfort in knowing that nothing is ever lost. If every moment is preserved, then your childhood laughter still exists, your first sunrise still burns, your loved one's voices still echo. They are not gone, they are simply in another chapter of the book, another frame of the film, another measure of the symphony. You may not have the ability to step backward and relive them directly, but their reality is not erased. The block universe holds them as securely as the present moment. Everyday life offers small tastes of this perspective. When you flip through an old photo album, you see faces and places as they once were. The moment is gone in your linear sense of time, but in the block universe it is still there, as real as the page you are looking at. When you revisit a memory triggered by a scent, the smell of rain on pavement, the aroma of bread in an oven, you're reminded that the past still holds weight, still exists in a way that shapes your present. The block universe simply extends this intuition. It says all of time, not just memory, exists in this way, equally real, equally present in the structure of reality. Some people resist this vision because it feels too rigid, too fatalistic. If everything is fixed, what about hope? What about dreams of change? But here again, a softer reflection can help. Hope is not erased by knowing the story is complete. It is embraced. When you read a novel you love for the second or third time, you still hope for the characters, even as you know how it ends. You still cheer when they succeed, still ache when they falter, still long for them to find joy. Hope lives not in uncertainty, but in caring, in the way you bring your heart to the story. In the block universe, hope is no less real. It is part of the performance, part of how meaning is made. Perhaps the deepest gift of this perspective is quiet acceptance. To see your life not as fragile moments slipping away into nothing, but as part of an eternal structure where every second already belongs, is to let go of some of the anxiety about what is lost. You cannot ruin what already exists. You cannot erase what is already preserved. You can only live, moment by moment, turning the pages of a book that has always been whole. So, as you listen tonight, perhaps you can let this vision settle around you. Think of your life as a beloved story you're rereading, or a favourite symphony you're hearing again. The notes are fixed, the ending secure, yet the meaning lies in the way you live them now, in this moment, in this breath. Paradoxes dissolve, not with clever tricks, but with the quiet recognition that every moment is already safe, already written, already part of a reality too vast to lose a single detail. After wandering through paradoxes, principles, and entire universes of possibility, it is worth pausing and looking at the ground beneath our feet. Because in truth, you're already a time traveller, even if your journeys are small, subtle, and woven into the ordinary fabric of your days. The grand loops and cosmic tunnels may be rare or unreachable, but the smaller distortions of time are with us constantly. Reminders that the clock is not quite as steady as it seems. Consider something as simple as jet lag. You board a plane in one part of the world, spend hours suspended in the thin air above oceans and continents, and land in a place where the clocks insist a whole portion of your day has vanished or stretched unnaturally. Your body lags behind, still loyal to the rhythm of the place you left, while the world around you has already moved forward. In that disorienting space between your watch and the local time, you're caught in a miniature time travel, not through paradoxes or wormholes, but through the way our planet spins and divides itself into zones. Daylight saving time is another gentle reminder. One evening you go to bed, and by decree of a clock you did not set, you rise to find an hour has been stolen or gifted. The sun rises the same way, the earth turns as it always has, but your schedule insists on a shift. It is a human-made version of time travel, a collective agreement that time can be bent by consensus. You may feel it in your sleepiness, in the confusion of your meals, in the way the day seems too long or too short. You have stepped, with everyone else, into a slightly altered flow of hours. These examples are not paradoxical. They are simply reminders that time, as we measure it, is flexible. Even without clocks, your body knows it. Think of how long minutes feel when you're waiting for a phone call, or how quickly they vanish when you're laughing with a friend. Time stretches and compresses in your experience, not as illusion, but as part of the way your mind and body track the world. Every moment you feel time slip differently, you're experiencing a private form of time travel. Physics, too, joins in this quiet chorus. Every GPS satellite orbiting the Earth must account for relativity. Their clocks run at a slightly different rate than those on the ground, and engineers adjust constantly to keep the system accurate. Without those corrections, your map would fail within days, the directions drifting uselessly. You do not feel it as you check your phone, but your journey to a cafe or a friend's house is guided by a form of time travel happening invisibly above you. Time, stretched and bent by speed and gravity, is measured, accounted for, and folded back into the convenience of your daily life. To make this even more tangible, consider your own body again. The top of your head is farther from the Earth's gravity than your feet, and so, according to Einstein, time is ever so slightly faster up there. It is an immeasurably tiny difference, detectable only with precise atomic clocks, but it is real. Your head is living milliseconds ahead of your feet, a gentle reminder that even within the space of your body, time is not perfectly uniform. You are, in a sense, constantly stretched between two slightly different futures. Perhaps the most comforting metaphor comes from the kitchen. When you bake bread, the yeast stretches time inside the dough. The moments expand, air bubbles grow, and what felt compressed becomes elongated. To watch dough rise is to watch time behave differently, not rushing, not ticking evenly, but stretching in rhythms that feel almost alive. In this way, even bread making becomes a kind of time travel, an everyday ritual that reminds you time is not rigid, but elastic. These small journeys may not carry you centuries into the past or future, but they are just as real. They remind us that time travel is not an exotic privilege of science fiction. It is woven into the way clocks, bodies, and experiences already function. When you cross a time zone, when you wake groggy from daylight saving, when you notice how quickly an evening passes with friends, you're experiencing the flexibility of time firsthand. And maybe that is the gentlest way to prepare for the more extravagant visions of wormholes and cosmic strings. You do not need to imagine vast machines or impossible paradoxes to know that time can be bent. You only need to recall the heaviness of an hour spent waiting, or the blink of an evening that vanished too soon. These are paradox-free travels, gifts of perspective, reminders that even in the smallest ways, the universe is already inviting you to drift differently through its hours. So, as you lie here tonight, think of yourself not as someone bound by the steady tick of a clock, but as someone already journeying in small but meaningful ways. Each breath, each heartbeat, each shift in light is its own form of travel. The cosmic adventures may still belong to dreams and equations, but the everyday ones are already yours. Not all journeys through time require machines, equations, or cosmic loops. Some of the most profound forms of time travel take place in the quiet space of your own mind. Every night as you drift into dreams, you step into a landscape where time bends, folds, and dissolves entirely, carrying you backward into old memories or forward into imagined futures without ever producing paradoxes. Dreams and memories are our personal time machines, gentle ones that require no fuel and produce no contradictions, yet feel as real as any physical voyage. Think of how a single scent can pull you instantly into the past. The smell of rain on pavement might carry you to a childhood afternoon, when puddles shimmered like mirrors and the world seemed larger than your small steps could cover. The aroma of bread baking can open a door to kitchens long gone, where voices and laughter mingle in memory. In those moments, you're not simply recalling the past as a faded photograph. You are living in it again, however briefly. Your body responds, your emotions stir, your mind places you in a time that is no longer now, and yet feels immediate. That is time travel, as natural as breathing. Dreams push this further. In a dream, you might walk the halls of a school you have not seen in years, or sit beside someone you have lost, feeling their presence so vividly it lingers even after waking. You might leap forward too, inhabiting futures that have not yet come, scenes of adventures, worries, or hopes that feel tangible in the dream's strange logic. Time in dreams refuses to follow a straight line. Hours can pass in seconds, or a single moment can stretch into eternity. You wake and realize the boundaries of time you cling to in waking life are not as rigid as they seemed. Scientists studying sleep often note how the brain replays experiences, consolidating memories and rehearsing possible futures. In this way, dreams are not random nonsense, but a kind of nocturnal theatre where the mind stitches together fragments of past and imagination to prepare you for what may come. It is rehearsal and remembrance blended together, a kind of time travel woven into the biology of rest. Everyday experience offers smaller versions of this too. Déjà vu, for instance, the strange moment when the present feels like it has already happened, as though you're remembering now from some forgotten future. Or the way nostalgia can transport you in an instant to an earlier stage of life, so that for a few moments you are both who you were and who you are, existing in two times at once. These are not paradoxes, they are gifts, reminders that time inside the mind flows differently than time on a clock. Philosophers sometimes point out that memory itself is a kind of time machine. When you recall an event, you're not just retrieving information, you're reconstructing the experience, reliving it from within. That is why memories can be so vivid, filled with sensory detail, and also why they can shift, blur, or adapt. The mind does not store the past like a perfect recording. It weaves it new each time, blending fact with imagination. In a way, every act of remembering is also an act of time travel into a slightly altered past. What makes this gentle is that it never collapses into contradiction. You can dream of meeting your younger self and no paradox emerges. You can imagine tomorrow's conversation and no law of physics breaks. The mind allows these leaps without tearing the fabric of reality. If the paradoxes of time machines trouble scientists, the paradox-free travels of memory and dream remind us that not all journeys need to be bound by the same rules. To bring this into an everyday metaphor, imagine a photo album. You open its pages and find yourself smiling at the faces inside. Each photograph is fixed, unchanged, but the moment of looking breathes new life into it. Memory works like that. The past is preserved in fragments, but every glance reanimates it, pulling you across time in ways clocks cannot measure. Dreams are like flipping through an album that also contains pictures of places you have never been, futures not yet lived, collages that mix real and imagined without distinction. Both are forms of travel, quiet, private, and deeply human. And maybe this is why, as much as we are fascinated by machines and equations, we return again and again to memory and dream. They are always with us, available without effort, transporting us to times and places we thought were gone. You can close your eyes and find yourself in a childhood room, hear a long-forgotten voice, or step into a future you long for. These are journeys no paradox can threaten, because they do not alter reality. They enrich it. As you lie here tonight, let yourself drift on this thought. You are already a time traveller. Each memory is a step backward, each dream a leap forward, each moment of imagination a sideways slip into possibility. You do not need a wormhole or a machine to taste the freedom of leaving the present. It is already yours, carried in your mind, safe and soft, waiting whenever you close your eyes. If dreams and memories remind us that time travel already lives within us, wormholes carry us back to the cosmic scale, where the very geometry of space and time becomes pliable. Einstein's equations, the same ones that allowed us to imagine closed time-like curves, also leave room for another marvel: tunnels that bridge distant points in the universe. These are wormholes, sometimes called Einstein-Rosen bridges, and they're often pictured as shortcuts through the fabric of space-time itself. To imagine one, picture a sheet of paper with two dots drawn far apart. If you trace a line across the sheet, it takes time to move from one dot to the other, but if you fold the paper so the dots touch, then suddenly the distance collapses to nothing. You can step directly from one to the other. A wormhole is that fold, not on paper, but in the fabric of the universe, bending vast stretches of space into a tunnel that connects distant regions instantly. The idea is more than science fiction. Wormholes arise naturally in the mathematics of general relativity, just as black holes do. In fact, they are cousins of black holes, solutions to Einstein's equations that describe strange bridges between regions of space-time. The mathematics does not forbid them. The difficulty lies in making them stable. Like soap bubbles, wormholes are fragile in theory, tending to collapse before anything can pass through. To hold one open, calculations suggest, would require something exotic. Matter with negative energy density, sometimes called exotic matter. Whether such a substance can exist in usable form remains an open question, and yet the possibility lingers because wormholes do more than connect space. They also connect time. Imagine two ends of a wormhole, one left near Earth and the other carried on a long journey close to the speed of light, or lowered into the gravity of a massive star. Time would pass differently for each mouth thanks to relativity. If the tunnel remained intact, stepping through would not only take you to a different place, but also to a different time. A wormhole could become a two-way time machine, its mouths opening onto separate pages of the cosmic book. This is where speculation begins to shimmer like heat waves on the horizon. Physicists cannot yet build wormholes, nor even say for certain that they can remain stable long enough to use. And yet the equations allow us to dream of them, and that is enough to fill both science and storytelling with their allure. Countless tales, from novels to films, have imagined stepping through such a tunnel to emerge not only in another star system, but also in another century. everyday life offers small metaphors for the feeling wormholes inspire. Think of the way a door can change your sense of place instantly. You open a door at home and step into a familiar room, but sometimes, in dreams, the door does not behave. You open it and suddenly find yourself in a place entirely different. Your childhood classroom, a train station, a landscape you have never visited. Wormholes feel like those dream doors, sudden, impossible shortcuts that bend your expectation of continuity. Or consider the experience of reading. You can spend hours walking through a long novel, feeling the slow unfolding of events. Yet with a single flip of the page, you can leap forward by decades or centuries. A wormhole is like that page flip, but in reality, an instantaneous passage between chapters that otherwise require long, patient travel. What makes wormholes so compelling in the context of paradoxes is that they do not necessarily create contradictions. If one mouth is shifted in time relative to the other, then travelling through simply places you on a consistent new page of the universe's book. The paradoxes of erasing yourself vanish because the wormhole acts as a structured bridge, not an arbitrary rewrite. The story still holds, just with shortcuts tucked between chapters. There is also a deep poetic resonance in wormholes. They suggest that the universe is not rigid, but playful, willing to fold itself like paper or weave tunnels like burrows. They remind us that vast distances may not be as absolute as they seem, that space and time might hide passages waiting to be discovered. Even if they never prove practical, the very thought expands our imagination, opening doors to wonder. And perhaps, as you rest tonight, you can feel the softness of this idea. The cosmos may hold secret hallways, tunnels threaded through its fabric, ways of connecting times and places in loops we can barely imagine. Whether or not we ever build such a passage, the possibility itself is a kind of dream, one that reassures us that the universe is not finished surprising us. Wormholes are not simply puzzles and equations, they are invitations. Invitations to think of space as flexible, time as layered, and journeys as potentially stranger than any road we have ever walked. They remind us that paradox-free time travel may not be a contradiction at all, but a quiet possibility tucked into the structure of reality, waiting like a folded page to be turned. Wormholes may be the most famous vision of cosmic shortcuts, but they are not the only ideas scientists have explored when wondering how time travel might slip past paradoxes. Physics, especially when it stretches into the unknown frontiers, is filled with proposals that hover somewhere between possibility and poetry. These are not established facts, but rather sketches, hints, and whispers. Pieces of a puzzle that is still far from complete. If wormholes are the dream doors we can almost picture, then concepts like exotic matter, quantum gravity, and cosmic strings are the unbuilt tools and missing ingredients of tomorrow's experiments. To make this gentler, imagine being in a kitchen with half a recipe in hand. You know the dish exists, you have smelled it, perhaps even tasted it somewhere, but the page in your cookbook is torn. The list of ingredients is incomplete. You might try to improvise, but without the missing elements, the dish never comes out quite right. This is what advanced physics feels like when it comes to time travel. We have equations that hint at possibilities, but key ingredients are absent, leaving us to speculate and imagine. Take exotic matter, for instance. The stability of a wormhole, as we mentioned, seems to require a substance with negative energy density, something that resists collapsing in on itself. Negative energy is not the same as ordinary negative like owing money. It is more like a peculiar form of pressure that pushes outward rather than pulling inward. We do not yet know if such material can exist in the amounts required, but small glimpses of negative energy do appear in quantum physics, like fleeting sparks in the strange vacuum of space. It is as though the recipe calls for a rare spice we have only ever seen a trace of, never enough to cook a meal. Then there is quantum gravity. the long-sought theory that would unify Einstein's general relativity, which governs the large-scale cosmos, with quantum mechanics, which governs the microscopic. At present, the two frameworks do not fully agree, like musicians playing from different scores. Somewhere, hidden in the mathematics we have not yet discovered, may lie a harmony that explains how spacetime behaves at its most fundamental level. If we find that theory, it might tell us whether loops, tunnels, or other paradox-free structures of time are possible. For now, we are like listeners hearing faint notes of a melody but not yet the whole song. Cosmic strings are another speculation. Thin, unimaginably dense filaments of energy stretching across space, relics from the earliest moments after the Big Bang. If they exist, their gravitational effects could be extraordinary, bending space-time in unusual ways, perhaps even creating paths that loop back on themselves. We have no direct evidence for them, but the mathematics leaves room for their possibility. To picture one, imagine a loose thread in a sweater. Tug on it, and the fabric puckers and warps. A cosmic string, if real, would tug on space-time itself, creating distortions that might serve as shortcuts or loops. What all these ideas share is their incompleteness, exotic matter, quantum gravity, cosmic strings. They are glimpses of a world we do not yet understand, and that is what makes them so enticing. They suggest that our current view of time is not the final picture, that the walls we see around us may not be permanent barriers, but only temporary fences, waiting to be climbed once we find the right tools. Everyday life offers its own echoes of this unfinished state. Think of a puzzle missing pieces. The image is partly visible. You can see mountains, rivers, maybe a house, but large gaps remain. You can guess what belongs there, but until you find the missing pieces, the picture is incomplete. Or think of an invention you cannot quite build because the parts have not yet been made. Centuries ago, people imagined flight but lacked engines, aerodynamics, and lightweight materials. The dream was real long before the Wright brothers took off from the sand at Kitty Hawk. In the same way, our dreams of paradox-free time travel may be waiting for discoveries not yet in our hands. It is important to approach these ideas with humility. They are not promises, not blueprints, but possibilities. And in that humility there is something comforting. It means the story of physics is not finished. It means we live in a universe still open to discovery, still generous with mysteries. Perhaps exotic matter will remain forever theoretical, or perhaps one day we will learn to coax it from the quantum fabric of space. Perhaps cosmic strings are only mathematics, or perhaps telescopes will one day glimpse their warping effect on starlight. Perhaps quantum gravity will reveal time itself as something far stranger than we have dared to imagine. As you listen tonight, you might find that this uncertainty itself is soothing. There is no pressure to resolve the paradoxes now, no demand that we already hold all the answers. Instead, we can rest in the knowledge that the universe is vast, patient, and still unfolding. Our role, like explorers staring at distant horizons, is to wonder, to imagine, to prepare. The future of physics is like an unopened book on the shelf, its pages waiting for the day we're ready to turn them. And maybe that is the real gift of these advanced ideas. They remind us that impossibility is often only a placeholder, a word we use when we have not yet discovered how. Just as flight once seemed impossible, and electricity once seemed like magic, time travel may sit quietly in that category. An idea waiting for the missing ingredients, the tools not yet built, the theory not yet written. Until then, we can imagine, dream, and let the mystery carry us forward. It can be tempting, after wandering through exotic matter, wormholes, and cosmic strings, to feel overwhelmed by how distant these possibilities seem. The ingredients are missing, the theories unfinished, the evidence scarce. But perhaps the true importance of these ideas does not lie in whether they will be built tomorrow or even 1,000 years from now. Their importance is in the way they invite us to dream. Science is, at its heart, a form of dreaming, structured, tested, disciplined, yes, but still an act of imagination that asks what if. Think of the explorers who once set sail across oceans without knowing whether land lay on the other side. They had no GPS, no satellites, not even reliable maps. What they had was curiosity and the willingness to let uncertainty carry them forward. Some journeys ended in disappointment, others in discovery, but all of them expanded the human sense of what was possible. In much the same way, physics sends out its explorers, not on ships but on equations, travelling into the seas of the unknown to see if there are shores we have not yet touched. Why does this matter for time travel and for paradoxes? Because every theory we entertain, every possibility we imagine, is a way of stretching our understanding of time itself. Even if wormholes never stabilise, even if cosmic strings remain mathematical ghosts, the act of wondering changes us. It shifts our perspective, helping us see that time is not a rigid arrow, but a fabric that may bend, stretch, or even loop. In this way, science dreams are like lanterns in the dark, lighting paths that may never be walked, but still illuminating the landscape. Everyday life offers countless echoes of this kind of dreaming. Consider a child building castles out of cardboard boxes. The castles may not withstand rain or last beyond the afternoon, but in the act of building, the child learns about space, structure, imagination. Or think of artists sketching visions of cities that may never exist. The drawings do not fail because they are never built. They succeed because they expand what we can picture. Science, too, sketches. Wormholes and cosmic strings may be sketches, but they allow us to imagine a universe broader than our present knowledge. There's also a quiet comfort in realizing that impossibility often dissolves with time. Flight, once thought absurd, became routine. Communication across continents, once a fantasy, is now as simple as a tap on a screen. Each leap was born from someone daring to ask questions that seemed foolish at first. Time travel may never join this list in the practical sense, but the act of imagining it prepares us for whatever discoveries do arrive. It keeps the doors open, the possibilities alive. Why then do paradox-free visions of time travel matter? Because they let us approach the subject with curiosity rather than fear. Paradoxes feel like walls, shutting down imagination with contradictions. But when scientists and thinkers suggest ways around them, through self-consistency, probability, many worlds, or the block universe, they give us permission to keep exploring. They say, perhaps the walls are not so final. Perhaps the universe is more generous than our diagrams suggest. This generosity matters not only for physics, but for the human spirit. To live without wonder is to live in a narrow cage. To live with it is to feel that the world is wider, that tomorrow may hold surprises, that even the most familiar experiences may hide deeper truths. When you let your mind drift toward wormholes, or exotic matter, or paradox-free loops, you're not just thinking about physics, you're practicing hope. You're reminding yourself that the unknown is not a void, but a field of possibility. Even the act of listening to these words tonight is a kind of science dream. You're allowing yourself to imagine time not only as the steady tick of a clock, but as a landscape with valleys and tunnels, rivers and branches. You may never step into a wormhole, but you have stepped into the possibility of it in your thoughts, and that is its own kind of journey. There is a lovely metaphor in the history of maps. Long ago, when cartographers reached the edges of their knowledge, they would sometimes draw dragons or sea monsters, filling the blank space with imagination. Today, our maps of the Earth are complete, but our maps of time and the cosmos still have vast blank spaces. Instead of dragons, we sketch wormholes and quantum models. These sketches may not turn out to be true in the literal sense, but they remind us of the vastness of what remains unexplored. And so, science dreams matter because they are not wasted, even if they never come true. They are invitations to curiosity, encouragements to humility, reminders that our present understanding is not the end of the story. They keep us awake to the possibility that the universe is richer than we know. As you drift towards sleep tonight, you might think of yourself as one of those explorers, not sailing ships or building machines, but sailing through thoughts. Every what if you allow is a step into that ocean of possibility. Perhaps you will find a shore, perhaps not, but either way, you have travelled. You have stretched the horizon of what you can imagine. And in that act alone, you have kept alive the most important part of science, the dream that tomorrow can reveal more than today. For all the theories, equations, and speculations, perhaps the most enduring reason time travel captivates us is not scientific at all, but emotional. Long before we learned to measure time with atomic precision, we carried it in our hearts, and in those hearts it often felt too swift, too irreversible, too unyielding. Time travel appears in our stories not because we need it to explain the cosmos, but because we need it to soothe ourselves, to imagine second chances, to dream of touching what feels forever out of reach. Think of your own life, the moments you would give almost anything to revisit. The first time you saw someone you loved and felt your heart shift without warning. The conversation you never had, the one that lingers in your mind with words you wish you had spoken. The train you missed by 1 minute, watching it pull away as you stood on the platform, realizing that all the hours of that day would now unfold differently. These are not cosmic events. They are small, ordinary details, yet they are the very fabric of what makes us long for time travel. We do not crave machines and paradoxes so much as the ability to step back into our own lives and adjust them gently, like smoothing a wrinkle from a bed sheet. Popular stories know this, which is why they often frame time travel around regrets and hopes. The hero does not always leap centuries into the past to change the fate of empires. Sometimes they only want to save a loved one, to fix a mistake, to choose differently. Even in the grandest science fiction, it is the personal stakes that draw us in. We recognise ourselves in those characters because we too carry unsent letters, unspoken apologies, paths not taken. Nostalgia is itself a form of time travel, paradox-free and constant. To look at an old photograph or hear a song from years ago is to feel the past pressing close, as though it never left. In those moments, you're both here and there, both present and past. No machine is required, only memory, tender and persistent. The longing to physically step back into that scene is natural, because in some sense, you are already halfway there. Hope, too, binds us to the dream of time travel. We look forward as much as backward. What if you could leap ahead to see how your life will unfold, to reassure yourself that the struggles of today bear fruit tomorrow? What if you could meet your future self, older and wiser, ready to whisper advice in your ear? These questions comfort us, because they make the unknown feel less frightening. Time travel promises not only second chances in the past, but glimpses of reassurance in the future. Even regret, which often stings most sharply, carries within it the seed of the time travel dream. To regret is to wish for a moment's return, a chance to walk a different path. But regret also shows how deeply we care, how much meaning we attach to our choices. Without that longing, time travel would not move us. The fact that it does is evidence that we value our lives, our connections, our brief moments of decision. Everyday life gives us small echoes of this yearning. When you catch yourself replaying a conversation in your head, changing the words, you're enacting a miniature time travel. When you linger at the window after a long day, imagining how differently things might have gone if you had chosen another route home, you're experimenting with alternate timelines in your mind. These thought experiments are not mistakes. They're part of being human, part of our ongoing attempt to make sense of the fleeting nature of time. There is also joy in this dream. It is not always about fixing mistakes. Sometimes we long for time travel simply to revisit beauty, to stand again in the glow of a perfect sunset, to hold again the small hand of a child before it grew larger, to hear again the laughter of a friend now gone. These are not regrets but treasures. and the idea of time travel tempts us because it suggests those treasures could be touched again. Philosophers might say that this longing reveals a deeper truth, that we're not only creatures of the present, but creatures stretched across past and future, carrying memory and hope like wings. Our minds are not bound to the single second ticking on the clock. They drift constantly, backward into what was, forward into what might be. The dream of time travel is simply an extension of that natural drift given form and story. And perhaps that is why the idea has lasted so long in our imagination. It is not merely about bending physics. It is about honouring the way we feel time, how we ache for what is gone, how we hope for what is coming, how we replay and rehearse the moments that shape us. The equations of relativity or quantum mechanics may one day show us whether time travel is possible without paradox, but even if they do not, the dream will remain, because it lives not only in mathematics but in memory and longing. As you rest tonight, you might let yourself drift into those personal time travels. Think of a moment you would revisit, not to change it, but to hold it again. Think of a future you would like to glimpse, not for certainty, but for comfort. These are the journeys that make time travel more than science fiction. They are what make it human. The dream of time travel often begins with regret, with the longing to undo a mistake, or with the desire to linger a little longer in moments that slipped by too quickly. Yet what if the very impossibility of stepping backward is not a flaw, but a feature? Not a loss, but a gift? What if paradoxes, instead of being cruel barriers, are gentle reminders that the present is precious precisely because it cannot be rewound? Think of a sunset. Part of its beauty comes from the fact that it fades. The colours bloom across the horizon, painting the sky with fire and gold, and then, almost before you have finished looking, they vanish into night. You cannot press pause, you cannot return to the exact same moment tomorrow, because each sunset is shaped by its particular clouds, its particular light, its particular you standing there to see it. If you could return endlessly, looping back until it grew familiar, would it still hold the same magic? Or does its fleetingness make it shine brighter? The same is true of watching a child grow. One day they fit into the crook of your arm, tiny and fragile, and the next they are running ahead of you, laughing, no longer willing to be carried. You may wish for a time machine to hold them again as they once were, but perhaps what makes the memory so vivid is precisely that you cannot. The moment was unique, unrepeatable, belonging only to its place in the river of time. To lose the ability to rewind is to gain the poignancy that makes every stage of life irreplaceable. Even something as simple as baking bread can remind us of this truth. You mix the ingredients, knead the dough, wait as it rises. Once baked, it cannot return to dough. The change is irreversible, and that irreversibility is what gives it meaning. If you could simply step back, undoing and redoing, the loaf would lose its significance. Instead, each batch carries its own story. The warmth of the oven, the smell filling the room, the way you shared it with others. Paradoxes are often painted as threats, as if they exist only to forbid us from touching the past. But perhaps they are better understood as protectors, quiet guardians of meaning. By making it impossible to return and alter, they preserve the uniqueness of each moment. They remind us that the arrow of time, pointing forward, is what gives life its flavour. If we could change the past freely, regret might vanish, but so too might wonder, joy, and gratitude. Everyday life confirms this in subtle ways. Consider a concert you attend. The music fills the hall, every note vibrating in the air, and then it is gone. You cannot rewind the sound itself, only hold the memory of it. It is precisely because you cannot return that you lean forward, listening more intently, knowing this performance is one of a kind. The paradox of time, that it moves only forward, is what creates the urgency that makes you present. Or think of conversations with someone you love. Words spoken are carried away on the air. You cannot step back to rehearse them, though you may wish you could. But their impermanence makes them honest, raw, alive. The impossibility of a second take is what gives the moment its weight. If paradox-free time travel meant endlessly editing and revising, life might begin to feel less like a story and more like a draft with no final form. This is why, perhaps, the universe resists paradoxes. Not because it fears contradiction, but because it values coherence. It does not allow you to erase yourself, not only to preserve logic, but also to preserve meaning. A life lived only once is fragile, yes, but also beautiful. The paradox of not being able to return is what allows the present to matter. So instead of feeling trapped by time's arrow, we might feel grateful for it. It carries us forward, through sunsets and bread rising, through conversations and laughter, through joys and regrets alike. And though we cannot rewind, we can savour. We can be more attentive, more present, knowing that what passes will not return. This knowledge is not punishment, it is invitation. As you rest tonight, let this invitation settle softly. The moments of your day are already preserved in memory, already part of the unchangeable fabric. Tomorrow will bring its own moments, equally unique. You cannot step back, but you can step into now more fully, aware of its fleeting beauty. Paradox is not a cruel wall, but a gentle reminder. Hold what you can while it is here, for it will never come again in quite the same way. And perhaps that is the truest gift of time travel's impossibility. We may not move backward, but we can move deeper into the present, noticing the small details, the warmth of light on your face, the sound of footsteps in the hallway, the rhythm of your own breath. These are the treasures paradox protects, the reasons life feels precious. And so, we arrive at the end of our long wandering through the landscapes of time. We have followed paradoxes as they twisted themselves into knots, and we have watched as principles, probabilities, and branching worlds try to untangle them. We have stepped into the quiet corridors of memory, drifted through dreams, and gazed toward cosmic tunnels that might connect places and centuries. Yet here, at the close of the journey, it is worth remembering that whether or not paradox-free time travel ever becomes possible, we are already living inside a mystery vast enough to cradle wonder. Perhaps that is the truest gift of this exploration. Science can sketch models, propose principles, and imagine futures, but beyond the mathematics and the metaphors lies the simple, unavoidable truth. Time is already stranger than we can fully understand. You feel it in the way a joyful afternoon vanishes in a blink, while a sleepless night stretches endlessly. You feel it when a scent pulls you back decades, or when a hope carries you forward years in an instant. These are not paradoxes. They are reminders that we live in a universe more flexible and more intimate than any single theory can explain. In this way, you need not wait for wormholes to open or equations to resolve before you can rest in wonder. The mystery is already here, humming in each second. Your life is a story unfolding, and whether it is written all at once in a cosmic block or branching endlessly in countless worlds, your experience of it is real, immediate, and irreplaceable. That is what matters most. Think for a moment of the ordinary anchors that have followed us through this journey. The bread rising slowly in the oven, stretching time in the rhythm of yeast. The missed train that became a symbol of regret and also of hope. The conversations you wished you could rewrite, and the laughter you wished you could hold longer. The sunsets, the music, the photographs, all these tiny markers of time's passage. They are not trivial, they are the threads that give the fabric its pattern. To imagine time travel is to acknowledge how much we care about them, how deeply they shape our longing. And perhaps the paradoxes we feared at the beginning were never enemies, only mirrors. They reflected our yearning to change the past, our wish to carry the future in our hands. Yet as we followed them, we discovered that contradiction dissolves in the light of gentler perspectives. Novikov reminded us that history may bend to include our actions, never tearing. Deutsch reminded us that probabilities adjust to keep consistency. The many worlds view offered us every choice, each preserved on its own branch. The block universe assured us that nothing is ever lost, that every moment belongs forever. And our own everyday experiences, jet lag, dreams, memories, showed us that time already grants us small journeys without paradox. So here, at the end, there is no need for urgency. You can let the questions soften. You can let go of the need for final answers. Science will continue to explore, and perhaps one day it will uncover a path through time free of paradox. Or perhaps it will not. Either way, you already live in a story rich enough for wonder, fragile enough for meaning, and mysterious enough to soothe you tonight. As you prepare to close your eyes, let yourself rest in that comfort. The day you lived is preserved. The tomorrow waiting will arrive in its time, and this moment, this very breath, is yours completely. You do not need to return to it, nor to travel away from it, because it holds everything you need right now: presence, stillness, and the quiet rhythm of being alive. And if your thoughts drift, as they surely will, let them wander gently. Let them imagine, if they wish, where you would go if you could step into time without paradox. Would you visit a long-gone evening of laughter? Would you glimpse a future filled with peace? Would you stand quietly in some forgotten corner of history? Or would you simply linger here in the now, recognizing that this too is a miracle? Whatever you choose, know that the wondering itself is enough. Time in all its mystery is your constant companion. It moves you forward, it folds into memory, it stretches into dreams. You're never outside of it, never lost from it, never truly separated from the moments you love. So let us close with gratitude. Gratitude for the scientist who dared to sketch impossible ideas, for the philosophers who asked impossible questions, for the storytellers who turned paradoxes into tales, and for you, listening here, carrying those questions into the quiet of the night. Thank you for being part of this journey. Whether your eyes are still open or already drifting shut, may you rest in the assurance that time, with all its puzzles and paradoxes, is also your home, and as sleep gathers you, may the universe feel a little wider, a little kinder, and a little more wondrous. Good night, traveller in time. Sleep peacefully, wherever and whenever you may be.